We've seen all of the characteristics and different data objects and importing data, and also a bit of visualization. Previous to that session, we'd seen a bit of data manipulation. How do you actually kind of work with data and try to filter it? But because there was a little bit of jargon, which we didn't cover in the basic concepts and the concepts that we'll cover today, if we can understand this, that will be more simplified. So today, let's concentrate on the different data types in R. Not just in R, in any analytical programming language, the data types are same. So let's have a look into that. Let's also do some variable understanding, which means independent variable, dependent variable, and what do they mean to the different algorithms that we try to use when we analyze data. And we'll look into the different steps as a brief summary as to how we go into trying to build an analytical model. So let's just have a look at data. First of all, we all know that data comes in structured and unstructured format. We will be focusing more on structured format at the moment. High-end algorithms will concentrate on unstructured data, but we will look into structured data. Now, what are the different data types that we have? We've got two types of data that we have. We have qualitative, quantitative. If you remember in the previous class yesterday when we were doing a lot of commands in R, and we said, the summary command will give us the quantifying variables and the categorical variables, this is what we were actually talking about briefly. When we get the output in numeric, it means it's quantified. That's basically what it is. And a quantified value, again, has two different options underneath it. And we'll look into that keenly. Qualitative is nothing but categorical data. The other name is categorical data, and we'd seen that yesterday too when we were talking of. We'd seen Bangalore city, that's a category. We'd seen gender, female, male, that's a category. So category data that's categorized is alphabets. And we've got three types of qualitative data. The first is binary. Binary is, it just has two outputs. True, false. Okay, pass, fail, yes, no, good, bad. It's just got only two outputs. That's binary. Now, nominal is, it is not binary. It's got many outputs it can have. It doesn't just have to limit itself to two options. Now, examples of nominal is, what are the top 5 schools in my area? What are the schools in my area? What are the streets in my area? Name the streets in my area. So it doesn't have an order, and it is not limited to just only 2 options. I have n number of options. That is nominal data. Ordinal data is nominal data, but it's got an order to it. Like when I take the schools in my area, I want to know the top 5 schools in my area. I'm giving it an order, top 1, 2, 3, 4, 5. Okay, so when I give the nominal data in order, it becomes ordinal data, like blood group, performance, good, excellent, good, not bad, bad. So there's an order to it. So a lot of questionnaire, when we do a lot of questionnaires, we have these kind of ordinal data. It is nominal data, but has an order. That is nominal data. So after qualitative, we've got quantitative data. What is quantitative data? It is again of 2 types. The first is discrete and the other is continuous. Discrete data is nothing but it is based on counts. And continuous data is nothing but it is measured on a scale. So the scale could have kilometers, length, size, width, Fahrenheit, temperature, all of that comes under measured. Discrete is based on counts, the number of parts that are damaged in a product, number of items stocked in the shelf today, the number of combs that I have in my shelf, the number of books in my bag. That is based on counts, and that's based on a measured scale. So that's the, and this is a very important chart that we're seeing here, because when we apply a statistical test to the data that we have, a statistical test will take data, whether it can be binary, ordinal, discrete. It has its own format, the way it can accept the variables that we have. So maybe if I take, let me take an example of linear regression. It is an algorithm. If I want to run an algorithm like linear regression, I first need to know, and I'm going to come in a little bit to what an independent and dependent variable is. I need to have continuous variables for linear regression. If I want to run logistic regression, I need to have my dependent variable as binary, but my independent variable can be continuous. So different statistical tests that we have accommodate only certain kind of data that is here. So as a data scientist, as a data analyst, as a statistician, when we go as a machine learning architect, I need, as a preliminary task, when I have data, I need to know which are the statistical tests that I can apply to the data. The algorithm can take only a certain type of data, and I need to know the different types of data that I have to hand, and what is it that that algorithm can support. And we will understand this as we go further. Now, I have an example here. I'm going to send this out to you, and I expect that most of us will have to do this exercise. I've got the name of customers, I've got the age, I've got the gender, I've got the marital status, the salary, and monthly credit card usage. 4 different customers. I want, and this is the data variables, the data types. I want you all to do this little exercise by telling me if age is what kind of a variable, gender is what kind of a variable, if it is categorical, is it binary, what is it? Marital status, what kind of a variable it is, and why is it? Annual salary, what kind of a variable it is, if it's continuous. Why is it continuous? Does it arise by counting or by measured scale? What is it? And monthly credit card. I want you all to kind of look into these variables, and from here you have to fill this for me, the type of variable and why do you call it that kind of variable. Okay, now when we get data to hand, the data set actually comes in records and columns, right? Rows and columns, that's how we get them. So all through we've been seeing importing a data set into R, the empty cars, the iris data set, we've seen all of that. And using the dimension command, we could actually see how many rows we have and how many columns we have, right? So when data comes to us like this, we need to know the column headers play a very important part, and we need to know, and we get them through using the names command, right? We've seen that. Now, why do we need to actually study these variables is because we need to know how to classify a dependent variable versus the independent variables. I could have many independent variables, but that one dependent variable, which is going to actually explain most of my data, has to be the crux of my data analysis. And we spend a lot of time trying to understand what that one dependent variable actually is. So let's take an example of what differentiates a dependent from an independent variable. Time spent studying causes a change in test score. But test score cannot cause a change in time spent studying. So what is the dependent variable? The test score. And what is the independent variable? I could have not just one independent variable which affects my test score, I could have many. The time that I spend studying affects my test score. The kind of course or the books that I read affect my test score. Probably, attending the best tutor in the city will affect my test score. So all of these independent variables will affect the dependent variable, right? So the independent variable influences change in the dependent variable. So the independent variable, which is the time spent studying, will influence the outcome of the dependent variable. Okay, so dependent variable is what you're trying to predict, and the independent variable is the information that we use to make the prediction. Okay, so those are the independent and dependent variables. So yet, when I was just talking about linear regression and logistic regression, when I say to apply linear regression, I will say my dependent variable should be logistic regression. My dependent variable should be binary, and my independent variable can be continuous. For logistic regression, my independent and dependent variables can be continuous and discrete. So for an algorithm, we need to know what your dependent independent is and kind of understand the different data types to actually apply an algorithm to the data that we have to have. Let's take an example of, if we go to all this, let's just try to understand different tests, the chi-square test, the t-square test, the ANOVA, the different tests that we have, that we perform, and we will see all of them as we go. But just to understand, when can I use a chi-square test? I can use it when my independent variable is categorical and my dependent variable is also categorical. I use a t-test when my independent variable is dichotomous and my dependent variable is continuous. So we've all seen this in the chart that we actually just studied here. All the variables are here. And for these variables, we will apply different statistical tests because that statistical test can accommodate only these variables. For a correlation, the independent variable can be dichotomous or continuous, but the dependent variable has to be continuous. For a multiple regression, we were just talking of multiple and logistic regression. The independent variable can be dichotomous, continuous, but the dependent has to be continuous. For a logistic, it has to be dichotomous, and it can be categorical or continuous. So depending on we need to study our variables and the data types before we can actually go ahead and do anything with it. To apply a statistical test and see if the sample actually satisfies a significant and a move ahead signal can be applied to the data that we're trying to do, we need to know which statistical test to run for what kind of data. So this is a very preliminary step and a very important step going through our exercise of understanding what the different data types will be. And that's the reason I would encourage that you just try to fill the variable types and give the remarks. Okay, now once we know what the data that we have to hand, we follow something called a CRISP methodology. We understand what the data is all about. That is very important. Okay, and we give it a business sense to the data. Why are we actually trying to work with the data that we have to hand? Why are we mining it? Is it that we want to give a bank the default rate, or get them to predict the default rate, or are we trying to give the bank some housing predictions for the next year, for the next couple of years? Or is it that we're trying to give an education sector a product that they want? So we need to understand the business and then really study the data. Data understanding is trying to get to know which the independent variables are. What are the different tests that we can perform on the data that we have to hand once we understood the data that we have there? And we need to prepare the data. Data preparation is nothing about cleansing the data. We've seen different packages like the dplyr Data.table package. We need to kind of prepare the data so that looks complete and ready for applying a model to it. After we prepare the data, we also need to transform the data, and we will look at data transformation in the next couple of classes, not the next class, but I think after 2 classes, we will look at data transformation. And then we will need to apply a modeling technique, which is nothing but a linear regression or a logistic regression or decision tree or any of the modeling techniques, and evaluate the model and deploy it. This is the methodology that we usually follow when we do this thing. Now, when we have data, we need to first understand what the business problem is that we need to solve. Right? We have a data model with all the different column headers: employee ID, employee name, tenure, okay, appraisal rating, change in appraisal, salary change, etc., etc., who their manager is, what is the technology, what is the project type, and stuff like that. Have they been abroad or not? This is our data model. Once we understand. Once we know what the data model is, we need to actually know what are the different analytical models that we're going to apply to this data. Are we going to apply something like a linear logistic? What is it? Then the first step that we need to do on the data is perform some basic descriptive statistics to the data that we have to hand. Once we know the dependent variables, using the statistical tests that we haven't gone through any of the tests, but we will be doing them as we go through. Whether we're applying a t-test or the z-test, or what kind of tests are we going to apply to the data. Even before that, we need to do one column analysis on data. When I have data and it comes to me this way, I want to know the maximum retail price, the average value of maximum retail price. What is the most frequent value in the column? What is the middle value in my column? All this is my descriptive statistics. I need to perform one column analysis of my data, which is nothing but your univariate analysis. After I perform univariate analysis, I will look at bivariate analysis. Bivariate analysis is how does one column of my data correlate with another column? What is the relation between two columns of data? What is the relation between age and the kind of role that they're doing at the moment? Are people who are more senior in age occupying more higher positions? What is the relation? Are people who have studied, have higher education, like PhDs, are they doing more qualified jobs? What is the relation between education and the job role? So that kind of analysis, understanding two columns, is correlation analysis. Now, I would do correlation analysis when data is numerical outputs and numerical predictors. I would do crosstab analysis when it is categorical output, which we just seen. After these steps are done, then I want to build my model, use a technique like logistic and build a model. And the most important part of any analytical project is a business narrative. I need to story tell what I've actually done in all the different steps, because the client sitting on the other end will not really understand what a descriptive statistic is, what a correlation is. He would want that in a very layman language, like, I need to story tell that using some graphical visualization and put it in very small, very concise storytelling format, what I've actually done. So that is a very important step that a data scientist actually does. And then ultimately, why do we do that? Because we want to give the best return on investment to any company. All they're looking for is actually the return on investment. So every company wants to actually either reduce their costs, or if they're investing, they want to know what is the return that they would get on the investments that they make. So ultimately, what we will actually be doing are these different steps that we've just actually seen. And data cleansing we've seen, and we will look into data transformation, but we will do that because data cleansing took a little while to study and understand. We thought, I'll put that to a later session when we cover more basic concepts. Any doubts as of today? And I'm going to give out this slide too. I'm going to upload it so that when you do your variables, you also cross-check, if you've actually done it the right way. I've given the variable type, and I've also given the remarks why we call number of credit cards to be numerical. I've given the justification for it. I would want you to actually do the work without looking through this and then cross-check your answers. And if you've got any more doubts, you can always come back to me. Any doubts as of today?